Hello, Mr. Sanger here, live from the prep room once again with a screencast for the pre-lab for a lab we're going to do on osmosis in potato cores. So how's this going to work? Well, the objectives, you're going to use potato cores and the concept of osmosis to determine the relative sucrose molarity of 6 solutions and of the potatoes themselves. That's a mouthful, but it's not that bad. Let's break it down and figure out what we're doing here. So for your pre-lab, basically the only thing you need to do is generate a data table based on the data you're going to be collecting. So in the actual Google assignment that tells you kind of about the lab and what you're going to be filling out, these instructions are there, and so you're going to basically read these and figure out, okay, if we're going to be doing this, what kind of data are we going to need to record? So that's your task for the pre-lab, is to generate this data table, and I'm going to leave it to you and your group members to figure out the best way to do that. So let me help you, though, by giving you a little background on this actual procedure and what we're going to be doing. So here's what you're going to be given. You're going to be given 6 different unknown sucrose solutions. They're going to be labeled A through F, and we will tell you that the concentrations are 0 molar, 0.2 molar, 0.4 molar, 0.6 molar, 0.8 molar, and 1 molar. And you're going to place each of those solutions into each of those 6 solutions into a different cup. Notice the cups are labeled A, B, C, D, etc. So your group is going to have its own set of cups, each of which has a solution. The trick is you don't know what A through F is in terms of what the actual concentration is. That's part of what your task is. You are then going to be given 3 potato cores per cup. So that's 18 total, 6 cups times 3 cores per cup. And the way you do that, there's a little picture over here that kind of shows this, but we're going to use, it's called a cork borer. And you're going to get like half of a potato, and you just basically use this to kind of dig in, and you make these little holes. And then the cork borers come with this little pokey thing, so when all the potato is stuck in there, you kind of just go whoop, and you just push it through, and boom, you have these nice little cores of potato. So we're basically going to give you half potatoes, and then you're going to use this cork borer to make 18 of these different things. And again, 3 are going to go in each of your 6 cups. You're going to get a balance and saran wrap. Why a balance? Well, because before putting them in the cup, you are going to mass each set of 3 potato cores. So I'm going to weigh 3 potato cores, and then I'm going to record that mass, and I'm going to put them in cup A. I'm going to weigh 3 more, record that mass, put them in cup B, and so on. So you're treating the cores as groups of 3. You're not individually measuring each one. You're measuring them in groups of 3. So what you're going to do is you're going to place those cores in the cups, and then you're going to fill those cups with these appropriate solution, A, B, C, D, E, or F. Please, these solutions are kind of a pain to make, so use just enough to cover the cores. Don't fill it up too much. And then we're just going to let it sit. It's going to sit 24 hours, and I'm sure you're going to have a restless night of sleep as you ponder what is going to be taking place. So let's preview what might be taking place. So what's going to happen to these potato cores as they sit overnight? Well, let's imagine that this beaker is filled with distilled water. Okay, the water potential of distilled water, of pure water, is 0. But now we have this potato core in there, and we know that cells have solute in them, and so the solute potential of the potato core is going to have a negative value because of that solute in the cell. So there's proteins, carbohydrates, all other stuff. So basically we have a water potential of 0 in the distilled water, and then a negative value for the potato core. So hopefully you're familiar with this concept of water potential enough to know that water goes to where the water potential is more negative. So water is going to be entering that cell. It's going to be going to where there's more stuff dissolved. But because potatoes are plants, their cells have cell walls. And so that cell wall is going to create a pressure potential. So as water is filling this up, eventually it's going to kind of push up against the cell wall, and it's going to limit how much water can actually enter that potato. And so yeah, basically that's what's going to happen. Now, the question of the lab is, what happens if we increase, instead of using pure water here, what if we increase the solute concentration to 0.2 molar? or 0.4 molar, 0.6, 0.8, 1. Is water still going to enter the potato core? Is there a point at which water might leave the potato core? We don't know. That's what we're going to figure out. And then we're going to use that information to actually identify which solution, A, B, C, D, E, or F, is our 0.2, or 0.4, or 0.6, or 0.8, or 1 molar. So the procedure, once they've sat overnight, you're going to, the next day, you're going to take the potato cores out, you're going to blot them dry on paper towels, and you're going to remass them. And of course, it's important to do a good job blotting them dry, because if they're sopping wet, that's obviously going to add to the mass. You also want to be careful not to wrap them around the paper towel around the cores and suck all the liquid out, because if you're sucking liquid out of the potato core, that's going to also affect the mass. You kind of want to blot nice and dry, kind of make them the consistency they were when you put them in the distilled water, and then reweigh them. And then you're going to determine the percent change in mass. So did the potato cores in each cup gain mass or lose mass? Then, as your post-lab activity, you're going to use that percent change in mass to determine the identities of each solution. So again, some will probably gain mass, some will probably lose mass, and it really depends on the difference in that solute potential between the cup, the liquid in the cup, and the potato core. So you're going to use, you're going to graph your percent change in mass data, and then you're going to use that graph to determine the actual molarity of the potato. And our hint for how to do that is you need to figure out what should the percent change in mass be for a potato in an isotonic solution. So that's an important hint. What should the percent change in mass be for a potato in an isotonic solution? So that's pretty much it. You're going to come in one day, you're going to carve out your potato cores, put them in a cup, you're going to let them sit overnight, you're going to take them out, you're going to reweigh and record the percent change of mass, and then using that and your knowledge of osmosis, figure out what these unknown solutions are. Good luck.